this video, I will talk about big O notation. Big O notation is a method for describing performance of an algorithm with respect to size of input. Algorithms are influenced by data provided to that algorithm. Now let's see the formal definition of big O notation. Let's suppose we have two functions, f of n and gn. F of n represents an algorithm. Okay, n is the number of input elements. F of n is said to be order of big O of gn if and only if there exists constant c greater than 0 and n not greater than or equal to 0, such that f of n is less than or equal to c multiplied by gn for all n greater than or equal to n. What this statement says is function f of n grows no faster than another function gn multiplied by some constant c for all n greater than or equal to n naught. Here c and n naught are constants. Actually, big O notation provides upper bound of the algorithm, that is the maximum amount of time required to execute the algorithm. Now let's see a simple example to know the big O notation of that algorithm. Okay, here I have written a simple sorts function. This function takes array of integers and item to be sorted within that array. Now let's see how much units of time will this algorithm or method take to execute. Here we have initialized variable n and assigned length of the array. So here two operations are performed. Now it will take 2 units of time to execute. Okay. Now we have the for loop. For loop, there is the declaration and initialization of variable I. So it will also take 2 units of time. Declaration and assignment, 2 operations. Now this I is less than n. So this will be executed n number of times. Okay. So this will be executed n units of time. Similarly, this I plus plus, this will be also executed n units of time. And this if statement will again executed for n units of time. Okay. Now this statement within the body of if will be executed only if this condition evaluates to true. So that will be executed, this block will be executed once, and within this block we have 2 statements. Okay. So 2 units of time. So in total, the number of units required to execute this algorithm is 2 plus 2 plus 6, then 3, there are 3n. That is the units of time required to this method. Okay, here this is f of n is equal to 3n plus 6. Now in order to check what is the big O notation of this algorithm or this method, let's suppose gn is equal to n. Now we have to consider c. Here in the big O notation we will not be considering this constant term. We will be using only the term with the variable. Here n is the variable. Here we have 3. So we will be taking 4 for the value of c, because gn is supposed to be greater than f of n. So we are taking the value 4, which is greater than this 3, the coefficient of this n. Okay. Now let's check when this f of n will be less than or equal to c dot gn. That is when this is f n will be less than c dot gn. Our f of n is 3n plus 6 and less than or equal to 4n. Okay. Now let's make a table 6 and 4n, and now let's take the value of n. Initially n is equal to 1. So this will give us 3 into 1 3 plus 6 9, and this is 4. When n is equal to 2, that is 3 to the 6 plus 6, that is 12, and this will be 8. Okay. N is equal to 3, then 3 3s are 9, 6 15, 3 4s are 12. Here till here our this function is greater, not this one. Okay. So we'll take 4, n is equal to 4, then 12 plus 6, that is 18. Now this will become 16. Now n is equal to 5, this will become 21. 15 plus 6, this will become 20. Now when n is equal to 6, then 24, this is and this is also 24. Now we are for the value of n. When it is 6, both the functions are same. This is f of n, this is c multiplied by gn, this is c multiplied by gn. Both are same. Now if we increase n and make 7, this will happen 21 plus 6, 27, and this will be 28. If we take n is equal to 8, then 8 3s are 24, that will be 30, that will be 32. Now from here, the value, as the value of n increases, now this part will be greater than this part. So what we can say here is, okay, f of n, actually we can say f of n is now less than or equal to c dot gn for c is equal to 4 and n greater than or is equal to 6. So therefore this function f of n is equal to O of gn. Here our gn is n. Okay, so in this way we can show this. Okay.